In this video, we are going to see how to set up and solve proportions, particularly relating to similar triangles. When you see similar triangles where you need to set up and solve proportions, you're going to see them really only in two different ways. The first way is they're going to be separate triangles, and the second way is it's going to be one triangle inside of another. So first we'll do separate triangles. That one tends to be a little bit easier, and then we'll talk about what to do if one's inside the other. So here I have two triangles. They're not touching, they're separate. Even if they were touching at a corner maybe, so I could get vertical angles, doesn't matter. Separate triangles. If I were you, I might redraw them so that they are facing the same way, so that like my angles, my corresponding angles are in the same location, because then it's a lot easier to see which are the corresponding sides. So if this had been spun and this was the one with 3 arcs, I might just spin it back so that it's on the bottom right, just like this one. When you set up a proportion between the side lengths of two triangles, the most important thing you have to keep in mind is that you need to be consistent. So before I even begin, I need to check that these two triangles are similar. This angle corresponds with this one, and the arcs show that they're congruent. Same with these angles and these angles. I'm actually given too much information here. I'm given 3 congruent angles. I only need 2 by the angle-angle similarity theorem. So these triangles are congruent because all of their angles these triangles are similar because all their angles are congruent. So now setting up proportions. There are a ton of ways to set up these proportions. I'm going to walk you through all of them because I'm not going to tell you how you have to do it. You can choose the way that fits best for you that you can remember. So one way to think about doing it is to put the two values, and if I was given numbers here, it doesn't matter whether I chose to do the 12 and the 6 or whatever numbers were here. The most important thing is that I have to include the x and its corresponding side, in this case a 10, otherwise I can't solve for x. So I'm not given numbers here, so let's ignore them. If I were, ignore them anyways because you only need one. So I could do left side over right side for each triangle. Left side over right side. That's one way I could do it. I could do the opposite. I could do right side over left side. So that would be x over 12 is equal to 10 over 6. That would be fine too. Or I can mix it up, so now I'm going between the triangles. This is probably the best way to do it, not the way I have it here, but the way I'm about to explain, because this is how you would find the proportion between the triangles to test if the sides are proportional and to find the scale factor. So if this really clicks to you, like put one side over the other, that's fine, as long as you make sure if I'm going to put my left side over my right, here I have to do the same left over right. If I had rearranged my triangle so that the corresponding sides are on the left or the right, etc. I could also match up corresponding sides between the two triangles. So I could do my big triangle over my small triangle, and that's going to be equal to my big triangle over my small triangle. Please note here that when I did big triangle over small triangle, here, these sides are corresponding. They're both between the 1 arc and the 2 arc. These, my x and my 10 are corresponding. They're both between 2 arc and 3 arc. So I couldn't have 12 over 10 and x over 6, but I can have 12 over 6, x over 10. Similarly, I could have put my small triangle as the numerator. So I could have done 6 over 12 is equal to 10 over x. Okay, all of these work. And the reason why all of these work is because if you look at the diagonals for every single one of these, you're always going to end up with 6x being multiplied together in each one. 6x is going to be multiplied together. And you're going to set it equal to 12 times 10 in each one. 12 times 10, that's the other diagonal. So that's why all of these proportions work, because once you set it up, the next step in solving it, it doesn't matter which one you had, you're going to end up with the same equation. So if I want to continue solving this, I know On my diagonals, I cross multiply. That means I'm going to get 12 times 10, or 120, is going to be equal to x times 6, or 6x. From here, just using algebra, I need to get x by itself, and I'm going to do so by dividing by 6 divided by 6. I know 6 goes into 12 twice. Leave the 0. So I'm going to end up with, sorry, this was kind of messy. When I had 12 divided by 6, one way I can do this is sort of ignore this 0 for a second. Say 6 goes into 12, this would go away, that becomes a 2. Leave that 0 back in. So I'm going, and that 6 went away when I divided it into 12. So x is going to be equal to 20. If this didn't make sense how I reduced that, you can reduce 120 over 6 any way that works for you. And you will get x is equal to 20. So this value here is equal to 20. It's a little trickier when you have one triangle inside of the other. And here's why. Because you might be given the entire length of the side of the big triangle, or you might just be given this part. So it's really important that you keep clear in your head what you're given and what you're doing. And as long as you're consistent, like if you are using this part, then that's fine, as long as you understand that that can't work for scale factor, and it's only going to help you find these sides. That's not going to help you find these ones, the ends. So my recommendation is to always look for the total big triangle that includes the small one. So if I could use subtraction to figure out that this value right here is 8, and even if they just gave me 8, I'm going to ask you guys to try to find the whole value of 12, because it's going to be easier to keep track in your mind. Because if you're always doing it that way, you can't make mistakes. So I have an x and a y I need to solve for. Again, I need to set up the corresponding parts. So if I were to separate these, and looking at, first I have to check that they're similar. I have parallel lines here. So I know that this one is congruent to this one by corresponding angles, and same thing on this side. And this angle is in both triangles by the reflexive property. So all of my angles here are congruent. I could separate this into two triangles. I have one triangle that has 4, 5, and 5, okay, with 1 arc, 2 arcs, 3 arcs. I have a bigger triangle with 1 arc, 2 arc, and 3 arc, and it's 12, 5 plus x. So my total side here, you see x is just this part. This total side is 5 plus x. Okay, that's very important. If I just write that this is x, for x I'm going to get this whole value. But x here, as it's clearly labeled, is just this part right there. And y. So, just like the last one, I need to set up a proportion here. So I'm going to set it up. I'm going to say I need to include the corresponding sides where I know both the values, so I have to include the 4 and the 12. Because if I just include the 5 and the 5 plus x and the 5 and the y, I have two variables and one equal sign. That's not going to work out. So I'm going to end up with 4 over 12, and that's going to equal 4 over 12, 5 over y. Let's start with y. 5 over y. Again, there are a bunch of different ways to write this proportion. This is the way that I saw it, and this is the way that I wrote it. But if you did it as a reciprocals, that'd be fine. And if you put 4 over 5 is equal to 12 over y, that'd be fine too. So I'm going to end up, I need to cross multiply here. And I'm going to end up with 4 times y, or 4y, is equal to 12 times 5, or 60. I divide both sides by 4, and I get y is equal to 15. Okay, so this value down here is 15. Now let's take a look at what I do about this 5 plus x. So I'm going here, now that I know that this is equal to 15, I could say 5 over 15 is equal to 5 over 5 plus x. I don't have to use the 4 over 12. I am because those numbers are a little bit smaller, so maybe they'll be easier to work with. 4 over 12 is equal to 4 over 12 is equal to 5 over 5 plus x. So here again, it's really important that we include this 5 plus and not just have it be x, or we're going to find the wrong value. Something you could do is you could leave this as x, solve for this entire side, and then subtract 5 to figure out what the true x is. So maybe you'd put that as w or something. I'm going to leave it like this. I'm going to cross multiply. This is a little trickier of multiplication. 4 times 5 plus x, but we remember algebra and we can do that. So I'm going to end up with 60 is equal to 4 times 5 plus x, 4 times 5 plus x. I'm going to need to distribute here, okay? So 60 is equal to 4 times 5 is 20 plus 4x. From here I subtract 20 from both sides. 40 is equal to 4x. Divide 4 on both sides. X is equal to 10. So this value of x is 10. Okay? Sorry, this got a little messy down here and ran out of room. So let's just take a look at these numbers and try to make sense of them. 4 on my small triangle goes to 12 on my big triangle. That's a proportion, or that's a ratio of 1 to 3, right? 4 to 12 is the same as 1 to 3. And when I had 4 to 12 here or here, I could have reduced before I multiplied. I chose not to, but if multiplying by 12 is something that's difficult, you should have done that. So 4, 12, 1 to 3. Same thing with this side, right? I found x to be 10, so 5 plus x, 5 plus 10, this side would be 15. 5 to 15. That's going to be 1 to 3. Same down here, 5 to 15, 1 to 3. So all of my sides are proportional, that proportion specifically being 1 to 3. What that means is that this small triangle is a third, its lengths are a third the size of this big triangle. Now let's take a look at these parts, okay? So this is something special for triangles inside of triangles when they're similar and these lines are parallel, because look at what happens. These side lengths, this one to this one, is going to be proportional to this one to that one. 4 to 8. 4 to 8 is proportional to 5 to 10. They both would reduce to 1/2. So that's also proportional. But be careful here, because I don't want you to get confused in saying that the scale factor of this is 1/2. It's not. It's 1 to 3. It's 1/3, or 3 over 1. While I'm on the topic of scale factor, I also want to just make a mention of that. I'll go back to this picture because it's a little less messy right now. So when finding the scale factor between these two triangles, the important thing that you have to remember is that there are going to be 2 scale factors for every similarity problem. One scale factor going from the big one to the small one, a shrinking scale factor, one that's less than 1, and you're also going to have a scale factor greater than 1 that tells you how to get to the small one to the big one. So if I erase this, give myself some room to work on scale factor here. So for scale factor, when we do scale factor, and I told you it would be okay to say 12 over x is congruent to 6 over 10, that's true when you're solving the proportion, but it's not true when you're doing scale factor. So that's why I'm going to leave these ones up, because we have to relate the corresponding sides. So I might have 12 over 6, and I just found 20 over 10. Here's why it doesn't matter which pair of corresponding sides you have, because I could have 12 over 6 or 20 over 10. They're both equal to each other, and they both equal 2. If I were to reduce these, I would get 2 over 1, which reduces to 2. So 1's possible scale factor is 2. What that means is that in order to find the sides of this big triangle, given the small one, I need to multiply them all by 2. To find what it would be going from the big one to the small one, sure, I could set my proportion up with the small one on top, 6 over 12, which is also equal to 10 over 20, which is also equal to 1/2. So I could flip the proportions and then reduce it to figure out what it is going in that direction. Or I could just, once I find one scale factor, take the reciprocal. So I have 2 scale factors for this problem. They are 2 and 1/2. Your scale factors will always be reciprocals. That is where you switch the numerator and denominator. Because my 2 tells me if I'm given the small triangle, I need to multiply my sides by 2 to get the big one. And 1/2 tells me if I'm given the big triangle, I need to multiply my sides by 1/2 or divide them by 2 to get the value of the sides for my small triangle. So that is scale factor, and we also talked about how to set up and solve proportions in this video.